Hello everyone, Josh Bond here, and I wanted to give you guys a few pointers, a few tips. Just when you thought you were done with me for the semester, I make a video and you have to listen to me again. Isn't that great? But hey, I think it will be great for some of you because I think some of you are making this harder than it needs to be. So I'm gonna give you some tips here and just point you to stuff I've already given you. Really, I'm just kind of just say, hey, go look at the code I've already given you. That's going to be one of my main messages here. But listen. I think some of you, the real difficulty here is you kind of feel like you're walking down the road blindly because I have you following these instructions, but you don't really understand what you're making, right? You're just trying to make something, but you don't understand the big picture. And I describe it up here a little bit, but rather than just read that to you, because I know you can read. Some of you don't like to read though, I noticed, but I'm going to walk you through a PowerPoint presentation here, just real quick to show you what you're actually making, like a visual guide to what you're making. So you're making a MyList class, and the code over here has already been given to you, right? A lot of it has, some of it has. The MyList class definition, size, capacity. And the third thing you're going to put here is a pointer. A pointer to, well, nothing right now. Initially, it's just going to be a pointer, right, of type integer. Eventually, though, this is going to point to an array. And the idea is you'll be able to use this class like we do down here in main, right? We have main down here, and we can add items to the lists. Now the list is really, in my list, it's a back-end array, and we're going to look at that in a minute. But the idea is you add items to it, and then when it gets full, right, it's initially sized to 5, so it's full at this point. The array will double itself. So in my list up here, this array will double itself. That's the big picture, what we're going to do. Now, zooming in just a little bit, what we're looking at here, size, capacity, you've already seen that code over here, right? Nothing new here. Then right here, we have the pointer. You're going to add that to your code. And then when you make your constructor, and let's just say, imagine like this is running, your constructor is going to set the size to 0. Because right now, how many items are in this array? Well, we technically haven't even made the array yet, so we're going to say it's 0. That makes sense, right? And then the capacity, how many items could the array have in it? Well, right now it could have 5. Why is it 5? Well, it's 5 because remember, over here, when we instantiate this class, and we pass 5 into it. If we pass 4, that would be 4. If we pass 6, it would be 6. You get the idea. So we set the capacity to 5. In the constructor, and you're going to write the constructor. You've been doing that for a couple weeks. It's nothing new. And then there is the array pointer. It's going to point to a dynamically created array that looks something like this, right? This is our dynamically created array here. It's out there in memory. There is no like X or Y or whatever pointing to that like a true alias, a true variable name. We only have the pointer, which is array pointer. So it literally, this class, my class, actually that's just saying my list. Sorry about that. Yeah, whoop, I got it wrong there too. My list. So my list points to this dynamically created array. And you say, oh my gosh, I can't do that. Wait, you can, because look at this. I've given you the code right here during the lecture, right? And it's out there under the course calendar. So yeah, this is how you dynamically create an array. Now I'm doing it here with a string, but you guys are really smart. I know you can just do this right here, integer, and lo and behold, it's going to break stuff all down here. But yeah, this is how you do it right here. This is called dynamically creating an array of strings. You could do this with an array of integers like I just showed you. You could do it with an array of anything, right? So that's how you dynamically create an array. I know a lot of you remember going over this, but maybe you just didn't see it's not triggering a, the vocabulary here maybe isn't quite what it should be yet. All right, so kind of moving further. So that's just the constructor, right? All of that was the constructor. You do all of that in the constructor, and it says right here, right? The constructor, you'll feed in the capacity of the list, which, is 5. Remember down here, we already went over that. Let's beat it to death again. Now, I don't mind. Let's see. Where am I at? ran the wrong one. That's why I can't find where I need to be. Actually, let me get back to where I need to be there. Save my spot. Down here, C5. All right. And you're going to set the size to 0. See, everything I just told you is right here. This is just sort of a visual representation of it. If you just follow these instructions, you shouldn't have any problem when you look at the lecture code, right? You're allowed to look at the lecture code. Not a problem there. Now, the next logical, I mean, we could talk about any of these, but let's go to add, because it makes sense, because right here in our code, look, what are we doing? I mean, I print out the size and capacity, just to verify it. But the first thing I'm doing is adding items to the list, which is really to say it's adding items to the underlying array, that dynamically array that we created right here, right? So let's do that. What does this look like? So the add method says add 3 to the size position of the array. Well, what is the size? Well, it's 0. Remember, it was 0 up here. It hasn't changed. It's still 0. Now, this is going to kind of change right now. It's going to become 1, but initially it is set to 0. Still, because it was 0 up here. Remember, we started with 0 in the beginning with the constructor, okay? So we add 3 to the position 0 of the array. And you say, but I don't know how to do that either. You've been doing that for like half a semester now, right? Look at this over here, lecture. See, it all comes back to the lecture. If we could take this pointer here, right? This pointer that points to this array of strings, and, we can say something like, well, let's just take it right here. Let's just copy and paste that. And we could say, position 0, and put, my name. Okay. Is that valid? Yes. No, you guys are, I'm just doing this for consistency. This is called pointer notation. This, this is absolutely doing nothing here at all. You can just take this out, and then once you take that out, you could just take this out, in this case. That's going to add it to position 0. If you were adding it to position 1, you would do this. Oops, sorry. That, position 3, not 31, but that, all perfectly valid. But in your case, you're going to do something like size, right? And this is going to throw an error here because it doesn't know what size is. But over here, you remember you have a size variable in your class, don't you? Of course you do. In your, up here, size. There it is. All right. So that's what you're going to do here. You're going to add an item to that location in the array. Now, you've been doing it this way before. Remember, you were doing something like this. 0, and you would put in something like that, right? That's adding the name Josh to the position 0 of the array, position 1 of the array, 2, 3, and so forth. Does the same thing up here, okay? And by the way, you can do it this way as well. You don't have to use, I'd like you to use pointer notation, but you don't absolutely have to. I'll let you get away with this if you want. It does the same thing. But yeah, I mean, that's how you do that. It's all been kind of covered here in the lecture code already, but you actually have to look at the code though, right? You gotta pull it up, you gotta download it from the course calendar, save it to your hard drive, pull it up, right? It takes a little bit of effort there. All right, so let's keep going here. I think we're on the right track. So look at this. And what happens if we add 5? Well, you see here, we add 5, size becomes 2. It was 1. It was 1 after we added the 3. We add the 5. And if you're wondering how I'm coming up with these numbers to add, these are just random numbers, but it does coincide, sorry, I'm in the wrong file, with what I'm doing here. I'm just tracing this code linearly, right? So we had 3, right? 3. Now we've added 5. Now we're adding 7. So when we add 7, we're adding it to position 2, right? 0, 1, 2. Now we add 2 to position 3, 0, 1, 2, 3, right? Position, it goes there. And you notice our array is filling up, right? That's what you're supposed to be seeing here, and you probably already noticed that. And look at that. Our array is full. Oh my gosh, what are we going to do? Well, that's sort of the whole point of this class, right? This, not the class you've been taking the whole semester, but this my list class. And by the way, I'm going to have to fix this. It's driving me crazy. My list. Let's just fix all these. Our array is full now. I think I want to fix it the whole way. I think I missed it. I think I misspelled it every time. So now our size becomes 5, and you notice at this point, because we're in the add method, right? See add right there, add. Now if we come back over here, you notice up here in our add method that I've already given you this. What's happening here? If size equals capacity. Well, look at this. After this happens, after 17 is added, the size is updated to 5. 5, the size is the same as capacity. You think that means something important? Of course, right? If size equals capacity, size and capacity are the same, then resize copy is going to be launched here, right? This method, that's when this method is invoked. Why? Because, well, we've run out of room and we need to make a bigger array. And that's what this method works on here, resize array. That's why we initially double the capacity. When we say double the capacity, what are we talking about? Capacity, right here. See capacity? Up here. Capacity. Bam. There it is, capacity and size. Remember, these are instance variables in the class. All right? So we double the capacity. And that's just a rule I've made up for this assignment. Does it have to be that? No, we could make it +1 or, whatever. But, in computer science, in the world of it, in most other data structures, the rule is you typically double it. And there's a lot of reasons for that we don't need to know right now. But we could have done anything, but, just I'm doubling it. That's all I'm doing. Whatever the old one was is now twice that. So that's what you're doing here with double the capacity. Now dynamically create an array. If only we'd done that before. Well, wait, we have, right? We just talked about that right up here with my little example. Back over here, remember we talked about dynamically creating an array. See that? We did it already. Granted, it's an array of strings, but int, now it's an array of integers, okay? So you're going to create a new array. Now this is the one that you already had, array pointer, right? Remember that back up here? Look at this. Array pointer right here. See that? Same one. Okay? Now, let me get back to my right spot here. Right. So array pointer, still accessing, nothing's changed over here. Those are the same numbers, right? We just added them a few moments ago. We create a new temporary pointer. It's temporary because sooner or later it's just going to disappear when this function goes out of scope. This is the resize copy function. When this goes out of scope, this will disappear eventually. But right now we're making a new array. You know how to do that. We talked about it a couple times in this little lecture alone, much less in class as well. Twice now in class. And you have the code from twice when I've done it in class, okay? You have the lecture code. So you're going to make another. So now we have 2 arrays and 2 pointers. That makes sense, right? This pointer points there, this pointer points here, okay? Now, what are we doing now? We're copying all the elements from one array to another. This can be done with a for loop. This is copying from one array to another is nothing new. I mean, it's something that you should be able to have done like in after exam, before exam 2, I believe. Yeah, copying from one array to another. Use a for loop. I can represent the position in both arrays, just like you did with the parallel arrays. You can almost view these as parallel arrays if you wanted to, because you're copying the contents one at a time. I is 0, copy that there. I is 1, copy that there. 2, copy that there. Just copy it from one array to another, okay? And then you'll have this. You'll have sort of duplicates now. All right? Next up, you want to, and again, if you're wondering where I'm getting this from, see, you're just going to, sorry, let me get in the right spot. Here we go, down here, resize copy. Set the capacity to double. Remember we just did that. Create a new local array, right? That would be this one right here, right? Temp pointer. It's all spelled out for you here. This is just sort of a dramatic PowerPoint presentation of it. Hopefully not too dramatic. But so down here, after you've copied everything, guess what we don't need anymore? Well, we don't need this old array. Why? What was wrong with this old array? Why do we hate the old array? Because it's too small, right? We're out of room. And somebody tried to add another number to it up here, right? We added 17, and we talked about adding, the next number. We couldn't. That's why we're out of space. So we deallocate it with a delete. We talked about this a couple of times. It's actually, you guessed it, in the lecture code. But hey, I pretty much just given it to you right here. That's what you call. You call it on the pointer itself. It deletes that memory. It's gone. And oh my gosh, we lost everything. No, we didn't. Remember, we copied it over right here. So we're all good. So now, this is pointing to nothing anymore. This is gone. Temp pointer is still pointing to this, right? Our new array. So how do we fix this? Well, come on down. Now we point array pointer to the same location, the same memory location as temp pointer. You're going to point this to this. In fact, I say right here, this pointer, array pointer, points to the address inside temp pointer. Okay? Each one was pointing to its own array. Now you're going to abandon this one by deleting it. Right? You delete array pointer. You're going to delete that. Then you're going to say something like, array pointer equals the address of temp pointer, right? So now that points there, and this still points here too, and that's okay. Can two arrays point to the same item? You betcha. And it will momentarily, but we don't need two pointers, do we? So what eventually happens here? Eventually this just disappears, right? When this resize copy function goes out of scope up here, man, why do I keep getting the wrong file? I have a problem with that, don't I? Resize copy. When this ends, when that, parentheses, when that scope ends, then this whole thing right here just disappears. And that's totally cool. Because now the array pointer points to the new dynamically created array. See, it's kind of a slick little thing we did here, right? We had this, we had both, we had this array here that was full. We created a new one, we copied everything over to it, and then once we were done with all of that and the deleting the old array, this array here kind of steals this one's address that it's pointing to, and then guess what? Sorry, buddy, we don't need you anymore. We're throwing you under the bus, temp pointer. You're gone. That's why it's called temp pointer, because we don't use it very long. So believe it or not, we've discussed most of the assignment. Except for the destructor. I'm not even going to talk about that because we just talked about how to delete the memory held by a pointer. That's what we just did up here, the deallocation. Right here. Set a pointer to null pointer or to zero. Again, discussed extensively in here, right? Search this file from null pointer, and you will be happy if you don't know how to do that. Or you could, dramatic gasp, read the book, but I know we don't want to do that. Hey, that's why I'm saving you from reading the book right here. Now, really what that leads is the remove method, okay? Now, and here I'm just going to go over this as well. So the remove method, this pretty much only works the way I have it coded right here. Sorry, in the wrong file again. We talked about that. We talked about this magical thing here. We get 0, 1, you get 1, 2, 3, 4, 5, and then then resize copy is called when you add the 6th item to the array. And then we get down here and we remove an item, right? This is just sort of looping through and showing you what's inside of the array. Just, for verification that what you did worked. The next big thing that happens here is we're going to remove an item. Now this is, this class is pretty limited in what it can do. It really can only remove this right here. The size of the list -1. So in other words, in plain English, this is removing the last item in the array. That's what this means. If there's 5 items in the array, then we're going to remove position 4 because it's 0 based. Because the first position is 0, the second position is 1, and so forth. So you won't change this code. In fact, you shouldn't change any of main. But just understand, every time we remove an item, we're really just removing the last item in the list, okay? And that's what I say here. When the remove method is called, remove the last item in the array. You don't even have to make that call, right? I mean, you just have to write the code that supports it. You don't write it. I mean, it's already written here, so you don't have to do anything. It's going to pass you a number. So all you do is remove that number from the array. And really, when we say remove an item from the array, all we're really talking about is setting that position equal to null. And you think, well, I don't know how to do that. Well, yeah, you do. You just don't know you do, right? Back to our little example here. Remember, this will be the parameter that's sent through this method right up here. Let me show you. Remove, where's it at? Right here. Index, right? So let's just call this index here. This is your pointer. Your pointer would have a different name. And you're just going to say no. This is going to error. Why? Because I don't have an index actually set up, but you do right here, right? If we copied and pasted this right here, it would work. So you're going to remove the index, which is the last position. Because that's all we're feeding into it. We're only feeding in the very last position of the array every single time. Every time we remove a number, I'm in the wrong file again. How many times am I going to do that? Every time we remove a number, I think we only remove one number anyway. It's the last position of the array. All right. And that's how you do it. You set it to null. Hey, I've given you the code, right? But I want you to understand it. It's important, really important, because next semester we're going to do a lot more with pointers, and you really, really, really have to understand it. Did I emphasize that enough? I hope I did. Now, so we're going to remove the last item in the array. Remove. I mean, literally, you're going to type this: remove parentheses and the index, right? That's what you're going to do. And of course, it's not going to cooperate on the spacing, but you get the idea. And so I think this side basically just says the same thing. Yeah, remove the last item in the array, which is 14, right? You got that? Pay attention to that, because something magical is going to happen here. 14 disappears because you're going to do something like this, set it to null. And then what else do you do here? We had 6 in the array, right? Do you believe me? 1, 2, 3, 4, 5, 6. And now we have 5 in the array, 1, 2, 3, 4, 5. So we set the item to null and then change the number in the array size. That's the number of elements in the array to 5. Because we have to update our class, right? And remember, got this little thing going on here that's irritating me that I made that little mistake. But yeah, my list object, you set it to 5 at this point, and you'll notice the instructions here: null, decrease it by 1. You just don't worry about the optional list. You just are bored, and that's it. And you say, what? No, that can't be it. Yeah, I mean, we've talked about everything. You don't have to do this if you don't want to. Resize, we talked about that. Conceptually, I hope you have a better idea of what it is you're doing. I've had some people say, hey, dude, I don't like your instructions. I just want to do it my way. I'm totally fine with that. Hey, man, go out in left field if you want. Actually, there's more than one way of going about some of this. You should not change the main code here. But hey, now that you understand conceptually like what it is you're doing, if you'd rather not follow my instructions, I think in the end you're going to be pretty close to this anyway, even if you kind of just do it your own way. That's fine. But don't change main, because I don't want you to go beyond the parameters of the assignment and kind of defeat the purpose of it. But yeah, if you just rather, and of course you'll have to mimic, you have to, make these method names and whatnot. But but if you just don't really like my comments here and you want to just kind of do it in your order and your way of doing it, that's totally fine, as long as you don't change main to do it. That's all I'm saying. But hopefully you kind of see now what I'm talking about here. Well, we have a list, my list. We have an array. This array gets full after we add too many items to it, and so then that's when we come down here and we create the second array. We switch this little sleight of hand where we switch the pointers. Throw this one under the bus because it goes out of scope. And if you're wondering, yes, you could actually keep adding and keep adding and keep adding, and this would keep on resizing the array for you. And if you try to put in some other number here, it's probably not going to work too well. I didn't really design this, for that. That's something we'll get into next semester. We're probably going to take this whole class next semester and build on it some more, because I think it's a good teaching tool to learn a lot of other things. But for now, if you do it, even if you do this correctly 100%, if you try to change this to some other number, you're going to get you may get some odd results that right now, you only need to remove the last item, kind of like I'm doing here. Just FYI on that. Any questions or problems, let me know. Send me your code and I'll take a look at it, try to get you back on the right track or tell you what you're missing. But give it a shot again if you haven't, or if you haven't already, give it a shot for the first time now that you've see what we're doing here. And I really recommend, like super strongly, that you go through this lecture code, because I mean, I literally give you the answers here. And yeah, so let me just comment that back out so that's not messing up anything. This is pretty important for the final as well. Understanding how to dynamically create an array of anything, strings, ints, doubles, whatever. And being able to use a for loop to populate that or just display it, right? Same idea that we've been doing all semester, using a for loop to go through an array, change the values, or to get the values from the array. Let me know if you have any problems or questions. I'm here to help you, and hope you have a good weekend and enjoy your time off. Thanks a lot. Bye-bye.